So, good day everyone. My name is Joshua Sarte and dito po kayo mismo sa another video, another topic, and another method po. So, simulan na natin guys. Analysis for lateral loads using cantilever method. So, yung reference na ginamit ko po is book po ni Cassie Mali. So, analysis for lateral loads using cantilever method. The cantilever method is based on the assumption that under lateral loads, the building frame behave like cantilever beam. Guys, kung sa portal method po, we analyze the frame as a series of portal. Dito naman guys, we analyze the frame as a cantilever beam. 'Di ba ang cantilever beam, it has fixed end. Ito guys yung fixed end and free end. And kapag natin po rotate ng 90 degree, ganito po yung magiging result. Parang cantilever beam talaga siya. So, the axial stress on a cross-section of a cantilever beam is subjected to lateral loads varies linearly with the distance from centroidal axis. So, ang minimin lang nito guys, ganito, may lateral loads lang, may lateral loads po tayo, cause po siya ng natural disaster po na or earthquake. 'Di ba po when it has disturbance, ito po kasi caused by an earthquake. When it has disturbance, it has stress. Ito po mismo is actual stress po. And bakit importante yung centered? Yes po, dun kasi guys, yung centered, dun po natin i-determine kung saan banda yung tension and kung saan banda yung compression. And kung dito guys, titingnan natin, 'di ba yung lateral loads is going to the right. And dapat yung position ng tension is sa left siya and yung compression nasa right siya. Actually, mai-discuss na lang yan kapag may example problem na po. And kapag nasa left naman po yung lateral loads po, yung compression po is nasa left side and yung tension is yung nasa right side. So, why do we consider using the cantilever method more than the portal method? Actually guys, hindi naman sa pagiging bias porket report ko, ito na mismo yung gagamitin. No, actually it has three factors. When it is high-rise building, mali yung. When it is So number one factor po, why do we consider cantilever method more than portal method is kapag po yung building natin is high-rise building. Kasi once ginamit po natin yung portal method sa ganitong pag-analyze po ng frame, yung makuha po natin na value ng shear dito, ng axial dito, ng shear dito, ng moment dito is hindi na po masyadong accurate kapag ginamit natin yung portal method. Okay? Kapag ginamit natin yung portal method, hindi na po masyadong accurate yung makukuha nating shear, moment, and axial sa bawat members. And number two po, when the frame has different cross-sectional areas in columns. So dito guys, kasi may mga problems na iba-iba yung area mismo ng column. Ito ngayon mismo is iba dito, and iba dito, and iba dito, and makita mo dito. So dyan pa lang guys, mismo dapat i-consider mo na gamitin ang cantilever method kaysa sa portal method. I mean, hindi naman mali yung portal method. Ang sinasabi ko lang na medyo malayo na mismo yung mga values ng portal method. Okay? Medyo malayo na sa katotohanan. Kumbaga, hindi na siya accurate compared sa cantilever method. And number three, when the distances are not the same. When the horizontal distances are not the same. I'm so sorry. Kapag ito guys, 4 nga ito, and this is 5, and this is 4, and dun pa lang, mag-cantilever ka na. And kapag guys, may characteristic, ang isa sa mga, kapag may characteristics po yung mga frames natin dito po, kahit isa lang dyan, meaning automatic, maggamit ka na mismo ng cantilever method. Okay po? So, The assumption made in the cantilever method can be stated as follows. So, an inflection point is located at the middle of each member of the frame. Ganun din po siya sa portal method. Actually, para magkapatid talaga ang portals and cantilever. And ganito din po guys yung assumption sa portal method. And number two, on each story of the frame, the axial forces in columns are linearly proportional to their distances from the center of the cross-sectional areas of all the columns on that story. So dito guys, I think mas better kung may sample problem. Basta ang sinasabi lang dito, importante yung pagkuha ng centered and dapat may basic tayo ng ratio and proportion. Basic knowledge pala. And yung procedure for analysis. The following step-by-step procedure can be used for the approximate analysis of building frames by cantilever method. So dito guys, number one, draw a sketch of a simplified frame obtained by inserting an internal hinge at the midpoint of each member of the given frame. So sabi daw dito, maglalagay ka daw ng internal hinge sa midpoint ng bawat member ng frame. Okay? Number two, determine column axial forces. Guys, di ba sa portal method, yung unang nahanap natin is column shear forces. Dito naman guys is column axial forces. Okay? Yun yung pinakaiba talaga nila. And dito, gagamit talaga mismo ng centroid and maghanap ng centroid and gagamit ng ratio and proportion. So, dito mismo determine the location of the centroid of all the columns on that story under consideration. So, centroid, maghanap ng centroid. Letter B, pass a horizontal section through the internal hinges at the column mid-heights, cutting the frame into two portions. So, it means ikakat down natin guys yung frame into two portions and may upper and lower. And i-consider natin yung upper. And malalaman na lang natin yan sa mga susunod na slides kasi may examples. Mas maganda. Assuming that the axial forces in the columns are proportionally to their distance from the centroid. So, ratio and proportion. Basic knowledge, guys. So, number 3. Draw a free body diagram of all the members and joints of the frame showing the external loads and the column axial forces computed in the previous step. Guys, 'di ba dun sa ginawa ni Sir Bonagua and dun sa book ni Casimali, we have joint dito, may joint diyan and in-isolate pa nila yung members and may column pa. Tayo mismo guys, gagawin na lang natin siyang as one, okay? As one siya. So it means parang ito mismo, i-merge lang natin siya para medyo madali yung solutions natin. So number 4, determine girder, shear, and moments. For each story of the frame, the shear and moments at the end of the girders are computed by starting at the far left end and working across to the right or vice versa as follows. To determine the moment at the girder's left end by multiplying the girder's shear by half the girder length, that is, moment girder is equals to shear girder times length over 2. And ano guys, 'di ba, for example, we have a frame dito. 'Di ba ang unang mahanap natin, 'di ba ang unang mahanap natin is the axial forces dito. And after nun, i-consider daw natin yung starting at the left end and working across to the right end. So it means pwede ka dito or dito pagkatapos mo maghanap ng axial forces. Okay? Ganun yung sinasabi. And itong formula nito is very important. Moment girder is equals to shear ng girder times length over 2. And yung number 5, determine column moments and shear. So, shear ng column is equals moment ng column over height over 2. Actually guys, itong number 5 procedure and number for procedure are just the same. So it means magfo-focus lang ako dito sa number 4. Okay? Same lang sila guys. Kasi yung solution na gagawin ko is medyo madali compared dun sa book ni Casimali and dun sa pagkagawa ni Sir Bonagua. So, number 6, determine Gauge axial forces. And number 7, use the three equilibrium equations of the entire frame to check the calculations. If the analysis has been performed correctly, then these equilibrium equations must be satisfied. So after guys natin makuha lahat ng numerical values sa mga members and i-consider natin mismo yung whole ng yung i-consider natin yung entire frame and dapat yung tatlong equilibrium forces, yung summation forces X, summation forces Y, at yung moment is dapat mag-equate to 0 or equal, okay? Malalaman na lang natin yan kapag may example na. So, simulan na natin. Let's start. Sa next video na lang guys.